algebra, let's look at our next section. We are still working with exponents, so we've still got some power going on. Today, we're going to talk about quotient of powers. Quotient means to, I'm hoping you said divide. Look, up there, it says division properties. All right, so we're going to look at what happens when we divide versus multiply. So far we've learned multiplication rules. So if I expand this, 2 to the 7th, I'm going to have 2 times 2, 3, 4, 5, 6, 7 2s, right? 1, 2, 3, 4, 5, 6, 7. Okay. Over how many 2's here? 4 of them. 1, 2, 3, 4. Okay. Now, what's that equal to? It's equal to 1, right? So I can cancel that out, that'll 1 out, that'll 1 out, that'll 1 out. How many do I have left? I have 2 to the 3rd power, right? Because it's 2 times 2 times 2, and 2 to the 3rd power is equal to 8. So when I divide these, I get 2 to the 3rd power, and that's equal to 8. Now, what about if there's t's? Is anything going to be any different? No. I've got t times t times t times t. And here I've got t times t times t. These will 1 out, 1 out, 1 out. What do I have left? I have t left. Now, look for that pattern again. When we were doing multiplication, we had some patterns and we could develop a rule. What do we notice about 4 and 3 and our answer? What's the exponent on this t? It's an imaginary 1. What do we notice between 7 and 4? My answer ended up being a 3, 2 to the 3rd power. What do I notice about these numbers? How did I get that 3? Well, that's where our rule comes from. Our rule comes from us finding those patterns and noticing those patterns. So, my A is my base, and what am I going to do with my exponents? I am going to subtract m minus p. So my top number exponent by my bottom exponent. I can only do that if they have the same base. So here I have x's and y's. I can't subtract this one from this one because they're x's and y's. So if you've got different bases, like here I've got g's and g's and h's and h's, and they're in a different order, you're going to have to first put them in order so that you can apply this rule. It will make it easier. You know, I mean, obviously you don't have to write them like that, but make sure you're looking at g's. If this was a g, g and g, not g and h, right? So match up the bases together, and then you're subtracting the variables, or the exponents, I mean. So for these g's, I'm going to get g, and then I'm going to have 3 minus 1, because this is a 3, and then there's an imaginary 1 there. And I'm going to have h, and I'm going to do 5 minus 2. If this step helps you, write that down. If that step doesn't help you, you don't need to write that down. You can do g, 3 minus 1 is 2, and you can skip this step if you want to. But if this step is helpful, don't skip it. That's silly, right? So here I've got h's, so I've got my h, and then I do 5 minus 2 is 3. Or I write that down, and then I go one more step, and I get g squared h cubed. That's my answer. Don't make this hard. Figure out how to do this, and go from there. So what's my base here? I've got an x, and I've got a y. I'd like you to come with those variables done, all right? Or those exponents done for each variable. So what's my exponent going to be? What's my exponent on my y going to be? Okay, so you come with that done. And right now we're going to look at another rule. So here I've got power of a quotient. Yesterday we learned power
to a power where we had, power to a product. So we had two things multiplied and we had a power. What did we do with it? Well, let's look at what happens with these numbers and let's see if we can figure out the rule. So if I'm looking at this, this is the same as 3/4 times 3/4 times 3/4, which is the same as 3 times 3 times 3 over 4 times 4 times 4. If I rewrite 3 times 3 times 3 with an exponent, I'm going to get 3 cubed over 4 cubed, right? And then I would evaluate that. But that's not really what I want you to look at. I want you to see the pattern. So what did you notice about the original problem to this? What did you notice? Let's look at one more just to see if we can see it. So I've got c divided by d squared. What did we do yesterday? We took our c divided by d. We've got two of them. We took our c divided by d's, and I set them up, and I got c squared divided by d squared, right? And so when I'm doing this problem, what did I do with the little 2? Well, I kind of like distribute it, right? So if I've got my a over my b, then my rule is that I'm going to put that m to both of those. So I'm going to put the m to here and the m to here. So I've got a to the m over b to the m. And then those aren't the same bases, so they wouldn't cancel out at all. But if they are numbers, I am going to evaluate those numbers. I'm going to figure out what that number is worth. Now look here at number 3. There's two things in here. So this here, this part here, is our rule from yesterday, where we have a product raised to a power. So we have to apply all of my rules all at once as I've learned them, and I need to make sure that I do this correctly. So what did I learn yesterday? I learned that I take my base and I distribute that 2 in, right? And I learned that if I have a power raised to a power, I'm going to multiply those. So I'm going to do 3 times 2. That's my rule, right? And so I just learned now that if I've got a fraction here, I need this to go down here. So this is going to be over 7 squared. But I'm not done yet. Now I need to figure out what all that means. And so 3 squared is 9. P to the 6th over 49. If I can reduce this fraction, I'd like you to. We can't reduce this fraction. Okay, we're going to do this one in class, and we'll talk about that because we have one more rule to talk about. Okay, so remember, if we've got our multiplication rules like the top here, we have to apply that. The division rule is the same thing as the multiplication rule, it's just being done on division. What about if I've got a 0 exponent? So my rule says, let's expand this. Let's write this as 3 to the 5th over 3 to the 5th. What am I going to get? This will cancel, that'll cancel, that'll cancel, that'll cancel, that'll cancel. So this is equal to 1, right? So what if I apply my rule? My rule is that if I've a number to a power over a number to a power, that I'm going to subtract those. I just learned that rule, right? First rule I learned. So if I do 5 minus 5, what am I going to get? I'm going to get 5 minus 5 is 0. So 3 to the 0 is equal to what? 1. Do you see that? All of these canceled out. All of them one'd out, making that 1 times 1 times 1 times 1 times 1, which is 1. if I apply my rule and then I look at this over here, I can see that 3 to the 0 is 1. So what's my rule for anything to the 0 power? Anything to the 0 power is always going to be the number 1. Okay? So if I look at this, I've got all of these exponents going on, but they're all raised to the 0 power. So this, I don't need to do anything with, because everything that's inside there is equal to 1. Because anytime I have anything in a parentheses and it's raised to a 0 power, or any type of base raised to a 0 power, my answer is 1. We're going to do 6 in class. Let's look at 7 we'll do in class. But let's look at 8. In 8, I have what? So here, I have a 5, right? And here, I have x to the 0 power. So I have 5 times, what is x to the 0 power? Wait, we just learned that. It's 1. That 0 is only on the x. It's not on the 5. So this answer is not going to be 1. It's going to be 5 times 1, which is 5. Okay? That's it. God bless. See you in class.